Our journey today takes us back to the 19th century to explore the life and works of James Clerk Maxwell. An extraordinary figure of his time, Maxwell was a Scottish physicist whose discoveries laid the groundwork for much of modern physics. His name might not be as instantly recognizable as Einstein or Newton, but his contributions are just as significant, if not more so. Maxwell is best known for his work on the theory of electromagnetic radiation, unifying electricity, magnetism, and light into a single theory. His equations, known as Maxwell's equations, are still widely used today and form the basis of technologies we take for granted, from radio and television to mobile phones. But beyond his scientific achievements, Maxwell was a man of many talents and interests. He was a poet, a philosopher, and a lover of nature. So who was this man who revolutionized our understanding of the physical world? Let's delve into his life and achievements. Maxwell was born on the 13th of June, 1831 in Edinburgh, Scotland. His fascination with the world around him was evident from a young age. Born into a family of knowledge seekers, Maxwell's childhood was a fertile ground for his curious mind. His mother, who noticed his keen interest in the natural world, nurtured this curiosity, encouraging him to ask questions and explore the world around him. At the tender age of 8, Maxwell's life took a tragic turn with the passing of his mother. His father then took on the responsibility of fostering his intellectual growth, sending him to the prestigious Edinburgh Academy. There, Maxwell's affinity for science began to blossom. His natural talent for mathematics and physics was apparent to his teachers, who were astounded by his ability to grasp complex concepts with ease. Maxwell's academic journey continued at the University of Edinburgh, where he engaged in independent research while still a student. His paper on the theory of elasticity, written when he was just 15, was one of the first signs of his extraordinary intellectual capabilities. At the age of 16, Maxwell embarked on a new chapter of his academic journey at the University of Cambridge. He thrived in the intellectually stimulating environment, making significant strides in his understanding of mathematics and physics. It was here that Maxwell began to formulate the theories that would later revolutionize our understanding of the physical world. His years at Cambridge were transformative, shaping his scientific worldview and laying the foundation for his future work. His professors recognized his potential and encouraged him to delve deeper into the realms of physics and mathematics. This support, coupled with his insatiable curiosity and brilliant mind, set the stage for the groundbreaking contributions he would later make. Indeed, those formative years were pivotal in shaping Maxwell into the scientist he would become. His years at university were transformative. They shaped Maxwell into the scientist we remember him as today. Following his education, Maxwell embarked on a journey of groundbreaking research. His curiosity led him to probe the mysteries of electricity and magnetism, subjects that had fascinated scientists for centuries. However, it was Maxwell who would make a leap in understanding that would forever change the course of physics. He began by studying the work of his predecessors, like Michael Faraday, who had observed that electric and magnetic fields were interconnected. Maxwell took these observations and translated them into the language of mathematics. He formulated 4 fundamental equations, which we now know as Maxwell's equations. The first equation, known as Gauss's law for electricity, describes how electric charges produce electric fields. The second equation, Gauss's law for magnetism, tells us that there are no magnetic monopoles in nature. The third equation, Faraday's law of induction, explains how a changing magnetic field can induce an electric field. And finally, the fourth equation, Ampere's law with Maxwell's addition, describes how electric currents and changing electric fields produce magnetic fields. These 4 equations are simple in their form, but profound in their implications. For the first time, they showed that electricity and magnetism were 2 sides of the same coin, intertwined in a dance that spanned the entire universe. This was a revolutionary concept, and it opened the door to a new understanding of the nature of light itself. Maxwell realized that his equations predicted the existence of waves that traveled at the speed of light. He proposed that light was nothing more than a ripple in the electromagnetic field, a wave of changing electric and magnetic fields propagating through space. This insight unified the fields of optics, electricity, and magnetism into a single theory of electromagnetism. Maxwell's equations, as they're now known, are the backbone of modern electromagnetic theory. Today, they continue to guide our understanding of the universe, from the tiniest subatomic particles to the vast expanses of cosmic space, all dancing to the tune of Maxwell's beautiful equations. Maxwell's influence wasn't just limited to electromagnetism. The scope of his curiosity and genius extended far and wide, notably making significant contributions to the kinetic theory of gases and thermodynamics. The kinetic theory of gases was a field that had piqued the interest of scientists long before Maxwell. However, it was Maxwell who introduced a novel concept that would change our understanding of it. He proposed that the speed of gas molecules wasn't uniform, but followed a statistical distribution. This idea, which might seem simple at first glance, was groundbreaking. It laid the foundation for what we now know as the Maxwell-Boltzmann distribution. This distribution describes the statistical behavior of a large number of particles in a system, providing an accurate prediction of their speed at a given temperature. Maxwell's work didn't stop there. He ventured into the realm of thermodynamics, a branch of physics that deals with heat and temperature and their relation to energy and work. Here he made another fundamental contribution. Maxwell proposed a thought experiment, now famously known as Maxwell's demon, which seemed to violate the second law of thermodynamics. This law states that the total entropy, or disorder, of an isolated system can never decrease over time. Maxwell's demon, however, suggested a scenario where this law could be violated. This led to intense debates and further exploration into the foundations of thermodynamics, pushing the boundaries of our understanding of the universe. Maxwell's work on kinetic theory and thermodynamics was not just about introducing new theories or concepts. It was about challenging existing ideas, pushing the boundaries of knowledge and daring to tread where others hadn't. His contributions were not just revolutionary, they were foundational, shaping entire fields of study and influencing countless other scientists who would follow in his footsteps. From gases to heat, Maxwell's insights were shaping the very way we understood the world, and in doing so, he left an indelible mark on the annals of scientific history. Maxwell's later years were as eventful as his early career. As he moved into the autumn of his life, Maxwell didn't slow down. He took the helm at the Cavendish Laboratory at Cambridge University in 1871. There he continued to push the boundaries of science, fostering an atmosphere of discovery and innovation that would become the laboratory's hallmark. Maxwell's tenure at Cambridge was a time of fruitful research. He delved deeper into the mysteries of electromagnetism and light, and his work in these areas was groundbreaking. His leadership at the Cavendish Laboratory also left an indelible mark, setting a precedent for rigorous scientific research that continues to this day. As much as Maxwell was a beacon of science, he was also a man of compassion and wit. He was known for his friendly demeanor and his love for poetry, often penning verses about his scientific theories. Sadly, Maxwell's brilliant mind was silenced prematurely. In 1879, he succumbed to abdominal cancer at the young age of 48. However, his death was not an end, but rather the beginning of a legacy that would shape the world of physics. James Clerk Maxwell's influence on the scientific world cannot be overstated. His equations laid the groundwork for modern physics, underpinning everything from radio and television to radar and mobile phones. His work has shaped our understanding of the universe, from the smallest particles to the vast expanses of space. Maxwell's legacy lives on through the countless scientists and researchers who have built upon his theories. His work continues to inspire new discoveries and innovations, proving that his contributions to science were not just significant in his time, but timeless. Albert Einstein himself credited Maxwell's work as the most profound and the most fruitful that physics has experienced since the time of Newton. That's quite an endorsement coming from the man who revolutionized physics with his theory of relativity. Though Maxwell is no longer with us, his influence on physics and our understanding of the universe is everlasting. His spirit of inquiry, his unyielding dedication to truth, and his contributions to science continue to reverberate through the halls of academia and beyond. And so, James Clerk Maxwell's legacy endures, lighting the path for future generations of physicists. In the span of just 48 years, James Clerk Maxwell revolutionized our understanding of the physical world. From humble beginnings, his thirst for knowledge led him to an education that would pave the way for his remarkable contributions. His groundbreaking work on electromagnetism, encapsulated in Maxwell's equations, forever altered the course of physics. Not stopping there, he further enlightened us with his insights into kinetic theory and thermodynamics. His intellectual prowess was not confined to his lifetime. Maxwell's theories continue to resonate through the corridors of science, influencing countless innovations and discoveries. His legacy endures, illuminating the path for future generations of scientists and thinkers. His work has touched every aspect of our lives, from the technology we use to the natural phenomena we observe. Remember, the next time you switch on your radio or look at a rainbow, you're experiencing the practical applications of Maxwell's brilliant mind. Thank you for joining us on this journey through the life of James Clerk Maxwell.